Week 3, Lesson 1. Relationships of exterior and interior angles of a convex polygon. Let us consider each convex polygon with all possible diagonals drawn from one vertex. By doing this, you can actually form triangles within each polygon. Complete the table below by writing down the number of sides and the number of triangles formed by the given polygons. Let us see this table below. We have the name of the polygons, the illustration, the number of sides, and the number of triangles formed. So first one, we have the triangle. So this is the illustration of a triangle. And as you can see, we have 3 sides. So triangle has 3 sides, 1, 2, 3. And of course, the number of triangles formed is only 1 triangle. Next one, we have the quadrilateral. So quadrilateral has 4 sides. So this is the illustration. And the number of sides, we have 1, 2, 3, 4. And the number of triangles formed is 2. So we draw a diagonal in the quadrilateral and form 2 triangles. The next one, we have pentagon. So this is the illustration of a pentagon. Pentagon has 5 sides. So we have 1, 2, 3, 4, 5 sides. And the number of triangles formed is, so we draw 2 diagonals inside the pentagon and form 3 triangles. Did you see a pattern on the number of triangles formed with respect to the number of sides of each polygon? Since we know that the sum of interior angles of one triangle is equal to 180 degrees, we can now compute for the sum of interior angles of each of the given polygons by simply multiplying the number of triangles formed by 180 degrees. Let us try completing the table that follows. So again, we have the name of the polygon, the illustration, the number of sides, the number of triangles formed, and the sum of interior angles. Let us have first the triangle. So this is again the illustration. The number of sides is 3 and the number of triangles formed is 1. And then the sum of the interior angles is 1 times 180 degrees, which is equal to 180 degrees. So here, you will just multiply the number of triangles formed by 180 degrees. And that is the sum of the interior angles. Next one, we have the quadrilateral. So again, this is the illustration. So it has 4 sides and 2 triangles formed. So to get the sum of the interior angles, you have to multiply the number of triangles formed by 180, which is 2 times 180 degrees is equal to 360 degrees. So that is the sum of the interior angles of a quadrilateral. The next one, we have the pentagon. So pentagon has 5 sides and we have 3 triangles formed. So to get the sum of the interior angles, you have to multiply the number of triangles formed by 180. So 3 times 180 degrees. So from there, we will arrive to a more generalized rule in finding the sum of interior angles of any polygon. So this is the polygon interior angles theorem. The sum of the measure of the interior angles of a convex polygon with n sides is n minus 2, or the quantity of n minus 2 times 180 degrees. So that is the formula. So to get the interior angle or the sum of the interior angles, you have to multiply n minus 2 by 180 degrees. Now let us have these illustrative examples. For number 1, compute for the sum of interior angles of a convex decagon. So this is the solution. A convex decagon has 10 sides. Use the polygon interior angles theorem and substitute 10 for n. So decagon has 10 sides. This is our formula. N minus 2 times 180 degrees. N is the number of sides. So substitute 10 for n. N minus 2 is 8. And then we have to simplify. 8 times 180 degrees is equal to 1,440 degrees. So that is the sum of interior angles of a convex decagon. For number 2, given the figure below, find the measure of angle C. A polygon has 5 sides, so the sum of the interior angle is 540 degrees. Let us refer to the second table. Add the measure of the interior angles and set the sum to be equal to 540 degrees. So here we have to find the measure of angle C. And we have the other angles, which is angle H, which is 75 degree, angle A, which is 150 degree, angle M and angle R is a right angle, so it is 90 degrees. So here you have to add the angles. The measure of angle C plus 75 plus 150 plus 90 plus 90 is equal to 540 degrees. So you have to add the similar terms. 75 plus 150 plus 90 plus 90 is equal to 405. Then subtract 405 from each side. So the measure of angle C plus 405 minus 405 is equal to 540 minus 405. So 405 minus 405 is equal to 0. And 540 minus 405 is equal to 135. So the measure of angle C is equal to 135 degrees. Next one, we have to find the measure of an interior angle of a regular decagon. So when we say regular, that means it is a equilateral and equiangular polygon. So solution, the sum of the measure of interior angles of a decagon is n minus 2 times 180. So the decagon has 12 sides. So that will be 12 minus 2 times 180. So 12 minus 2 is 10. 10 times 180 is 1,800 degrees. Since the dodecagon is regular, each angle has the same measure. Since we just divide the sum, which is 1,800 by 12 to get the measure of one interior angle. So 180 degrees divided by 12 is 150 degrees. So the measure of an interior angle of a regular dodecagon is 150 degrees. So from here, we can have more generalized formula in getting the measure of one interior angle of any regular polygon, and that is n minus 2 times 180 degrees divided by n. And for number 4, if the certain polygon's sum of interior angle is 2,700 degrees, how many sides does the polygon have? So, dito naman sides ang hahanapin natin. So, if we let S be the sum of the interior angle, this will be our formula. S is equal to the quantity of n minus 2 times 180 degree. So, since we are looking for the number of sides, let us manipulate the formula. S is equal to n minus 2 times 180 degree. And then, S, or the sum of the interior angle over 180 degrees is equal to n minus 2 times 180 degrees over 180 degree. Divide both sides by 180 degrees. Then we have S over 180 degrees is equal to n minus 2. So, S over 180 degree plus 2 is equal to n minus 2 plus 2. Add 2 on both sides. And then S over 180 degrees plus 2 is equal to n. By using the symmetric property of equality, this will be n is equal to S over 180 degrees plus 2. Let us use the resulting equation to answer the problem. So n is equal to S over 180 degrees plus 2. Substitute the given value of the sum of the interior angle, which is 2,700 degrees over 180 is equal to 15 plus 2. So n is equal to 17. So the polygon has 17 sides. Now let us proceed to the polygon exterior angles theorem. The sum of the measures of the exterior angles of the convex polygon, one angle at each vertex is 360 degrees. So the measure of angle 1 plus the measure of angle 2 plus the measure of angle n and so on is equal to 360 degrees. So let us have this illustrative example. Given the figure below, find the value of x. So we have the given value 80 and 120. Let us find the value of x. So for the solution, first we have the polygon exterior angles theorem. X plus 80 plus 120 is equal to 360. Then combining like terms, so we have to add 80 plus 120, which is 200. And then subtraction property of equality, we have to subtract 200 from each side. So that will be x is equal to 160. So the value of x is equal to 160 degrees. For number 2, given the figure below, we have to find the value of x. So we have the pentagon. So same solution, polygon exterior angle theorem. And then combining like terms. So 60 plus 95 plus 83 plus 52 is equal to 290. And then subtract 360 minus 290 is equal to 70 degrees. So therefore, the value of x is equal to 70 degrees. Then we have a convex heptagon has exterior angles with measure 30, 33, 45, 54, 67, and 79 degrees. What is the measure of exterior angle of the 7th vertex? Okay, so let x be the 7th exterior angle. Then add the similar terms. 30 plus 33 plus 45 plus 54 plus 67 plus 79 is equal to 308. And then 360 minus 308 is 52. For the regular polygon, you will just have to divide 360 over their sides.